Rational numbers and rational expressions. So if you look at the word rational, embedded in there is the word ratio. And what that means is that everything that we're dealing with can be expressed as a fraction. So this is a unit on fractions. And again, not like the warm-up where we had just numbers. We're going to have numbers and letters involved. So the numerator and denominator are both what we call expressions. So expressions are a combination of letters and numbers. Also, do you remember what's a no-go for the denominator? What can it never equal?
0.
0, yeah, good. So the denominator can never be 0. So we're going to be on the lookout for that. We've got to make sure that we keep our denominator a number other than 0. It can be negative, it can be positive, but 0 is a no-go. All right, so for these problems, I like to use a stick-it note to help myself look at it one piece at a time. So I'm going to start with number 1, and I'm going to cover up all of it except for the fraction. Does that look like our warm-up?
Yes.
Yeah. So let's start with that. We can do that. I know we can because we just did it. What divides evenly into both 10 and 25? 5. How many times does 5 go into 10?
2 times.
2. How many times does 5 go into 25? 5. Okay, so the first thing I'm going to do is reduce my fraction. I'm down to 2/5. Okay, we've seen these types of problems before. Let's see what we remember about them though. If we have x squared over x to the 5th, do you remember how I reduced those? Minus, yeah. So you always do bigger minus smaller. So I'm going to go 5 minus 2, and so I get x to the 3rd, and then your variable lives where the bigger exponent was. So because the 5 was bigger than the 2, it's going to live in the bottom. And we talked about a different way to think about this. So remember, x squared is x times x. It's 2 x's. X to the 5th would be having 5 x's. And if we cancel, do you see how there are 3 x's left?
Yes.
Or x to the 3rd, and they're in the bottom. So again, if it helps, you can always draw out kind of a little diagram.
Why did you not write x to the 2nd next to 2? Right there.
Right where?
Right, that's your final answer. Yeah, why didn't you write x? No, up. Yeah, why didn't? No. On the 2, yeah, why didn't you write x to the 2nd power like you did for the 5 to the 3rd power?
Because it's gone. They all disappeared from the top.
So then why doesn't it go to the top though?
It always goes where the bigger exponent is.
Okay.
So you're going to do 5, the bigger minus the smaller, so 5 minus 2 is 3, and then it lives where the bigger was.
Alright.
And again, if you want to draw it out to help see what happens, like this is the picture of me looking at like, okay, everything did cancel out in the top, and then I have 3 x's left in the bottom. Okay. Let's play the, go ahead.
If the top one was 5 and the bottom one was to the 2nd power, it would be on the top.
Correct.
Gotcha.
Correct. It lives wherever the bigger exponent is. All right, so I'm going to take my stick-it note and uncover all the rest. So we've got y's to deal with as well. So when I subtract, I'm going to do what minus what?
4 minus 3.
4 minus 3, which gives me 1. And because the 4 is bigger, it lives in the top. So this is going to be my final answer.
Oh, that's it?
That's it for those.
Oh, we lit.
We're going to get a little trickier. Not much,
Oh, darn it.
but a little bit. Okay, so do you see how these were only one term? Like there's no addition, there's no subtraction. It's just like we had 5x squared or we had a, okay. So these are a little bit different because do you see how we have multiple terms?
Yes.
Okay, so we need to think back for a second to our different factoring methods. So I'm going to make us a list off to the side over here because we're going to have to factor again. The good news is there are only 3 methods. So here are my factoring methods. Number 1, is pulling out something they have in common. So a common monomial. Remember, I don't care that you know the names, right? You don't need to know that this is called a common monomial, but you need to be able to recognize it and actually factor it. So let's say you had 10x plus 30. Say you came across that. Is there something these two numbers have in common?
10.
10, right? I could take a 10 out of both. So remember, this was like reverse distributing. So in parentheses, if I pull out a 10, I'd have x plus 3. Because 10 times x would get me back to 10x, and 10 times 3 would get me back to 30. Okay, so that's an example of a common monomial. We also had something called a difference of squares. And this is when both the things we had were a perfect square. So x squared is a perfect square, 9 is a perfect square, and it says difference. Difference means subtraction. So let's remember how to factor this one. It factors into two sets of parentheses. This is the one where we have a plus and a minus. And remember, we talked about the order doesn't matter. So it could be minus then plus, right? It could go either way. What is the square root of x squared? If I square root x squared, what do I get?
All x.
Just an x, yeah, good. So the x goes here and here. If I take the square root of 9, what do I get? What times what gets me to 9?
3 times.
Yeah, 3 times 3, yeah. Okay, so that's your difference of squares. The other one that we learned was called a trinomial. Let's go with this one. So a trinomial is kind of what it sounds like, right? It has 3 things. Triangle has 3 sides. Tricycle has 3 wheels. So that prefix, tri, means 3. So we have 3 terms here. This one we get 2 sets of parentheses as well. To get back your x squared, you have to do x times x. So it's kind of similar to the difference of squares. We need 2 x's. This is the one where we have to play a game, though. Do you see how everything's positive?
Yeah, make it negative.
Well, no, we're gonna keep it positive. Here's the game, though. We need to figure out what multiplies to 12 that adds to 7. So let's start thinking about 12. What are our numbers that multiply to 12?
1 and 12.
1 and 12. I heard 4 and 3. What else?
6 and 2.
6 and 2. So I made my list. Those are all the things. Of these pairs, which one is going to add to 7?
4 and 3.
4 and 3. And it doesn't matter which one I put where. I could have gone 3 first and then 4. Or you can go 4 then 3. It doesn't matter. So this was how we factored these. Okay, so just a friendly reminder so you can use that as we factor. So let's look at these problems now that are a little bit trickier than number 1. Okay, I always look through them in this order. So I put them in this order for a reason. I always look for common monomial first, then difference of squares, and then trinomial. So let's start with number 2 with just the numerator. So I'm going to cover up everything else. Not even going to think about any other piece of it. So look at just 2x plus 10. Is there something in common?
Yes.
Yes. What can I take out?
2.
2, yeah. Okay, so then we think about our parentheses and we think, okay, what's left over? 2 times what would get me back to 2x? I need an x. 2 times what would get me back to 10? 5. Okay, so I factored the top. So when you have multiple terms, this is going to be our process that we're going to go through and factor stuff. All right, let's look at the bottom. Which one is the bottom of our 3 choices over here?
Different squares.
Difference of squares. So we need 2 sets of parentheses. One gets a plus, one gets a minus. What do we know the square root of x squared is? X. So that goes here and here. How about the square root of 25? 5. That goes here and here. So the cool thing about fractions, and honestly one of my favorite things in math, is when stuff cancels out, so you have less things than what you had originally. Whenever you have the same thing in top and bottom, just like this problem up here, whenever you have the same thing in top and bottom, it cancels. So what parenthesis is the same in both the top and the bottom? Yeah. So this can go away completely, and I just have 2 over x minus 5. So again, we're going to factor, and then we're going to cancel anything that can cancel. And then this is going to be our final answer. So once everything is gone that can be canceled, we can box that in. That's going to be our final answer. All right, let's take a look at number 3. Look at the numerator first, just the numerator. That's kind of a boring numerator. Is there anything I could really pull out? No, I mean I could pull out a 1, but that's not exciting, right? So I'm just going to leave the numerator alone. There's nothing I can do to it. It's as simple as it can be. The bottom. Which type of factoring is the bottom? Which one? Trinomial. So we need 2 sets of parentheses. I know I have to have x times x, because that gets me back this x squared right here. All right, let's play the game for 8. What multiplies to get you 8? 2 and 4. What else? 1 and 8. Okay, so always remember that 1 and the number can be another one, and that should be it. Oh shoot, this one is wrong. This should be a 9, friends. Can we shimmy this into a 9? This is not. I'm not doing any math here. I'm just fixing the problem. The problem should not have been a 7x, because that doesn't work. Okay. Now let's do the problem. This is going to make more sense at this point. Which one of these is going to multiply to 8? Both of them do, but also add to 9.
No.
2 and 4 don't.
1 and 8.
1 and 8. Okay. So, what do I have that's the same in the top and bottom?
1. 1.
X plus 1.
X plus 1. So it's that whole thing. So in the bottom, I have x plus 8. What do you think I put in the top? Thoughts?
The X plus 1? No.
So the x plus 1 is gone.
0.
So if I put a 0 there, think about 0 divided by anything is 0. So that would make the whole thing disappear. So what we do, I kind of think of it as a placeholder. So if you use up everything, either in the numerator or denominator, there's a 1 hiding there. Okay, because remember we even talked about that. I said, could you pull out something in common? And I said, yeah, we could pull out a 1, but that's not exciting. All right, so there's that 1 that we could have pulled out. So this would be our final answer here. All right. What questions do you have? We're going to practice. We don't have a lot, though. We don't have a lot is the good news. Okay.